Hello everyone, how are you? I hope you are all fine. So I am here to discuss today about the theorems related to composite functions, one of which I have already discussed in the last video. So let's get proceed. Theorem 2. If f is a function from a to b and z is a function from b to c are the functions which are onto then the composite function z0 f from a to c is also onto. So the theorem is about if we have two functions given which are onto, then we need to show that their composite function is always onto. So the proof will be, since z from b to c is a onto function, since z is onto, let us suppose z be an arbitrary element in C. If we suppose Z as an arbitrary element in C, then there exists an element Y in Y belongs to B such that we always get Z of Y equal Z. Since Z is onto, if we take Z as an arbitrary element in C, then there exists always an element Y belongs to B such that Z of Y equal to Z. Similarly, since f is also an onto function, therefore for any x belongs to A, for any element x belongs to A, we get f of x equal y, where y belongs to B, since f is a function from A to B. So we have to show that the composite function of f and z is onto function. Therefore, z not f of any element x, suppose, and by definition of composite functions, we can write it as z of f of x. Now, f of x is nothing but this is equal to y, as we have given that f is onto function. Therefore, g of y. The next part is g of y is nothing but z, because we are also given that g is also an onto function. Therefore, z not f of x equal z. Now we can see here, for any element x in A, we get z not f of that element is equal to z, which is in C. We have already taken that C belongs to C. For any element x in A, we get another element z not f of x equals z, which is in C. Therefore, we can directly say that z not f is onto function. This is fulfilled whenever we are given that g and f are two functions which are onto. Therefore, this composite function g naught f from a to c is onto. Here it is a solution. G naught f of x equal to z. Finally, we have got this. Therefore, we can directly say g naught f is onto function. This is the theorem 2. So let's proceed to the theorem 3. Statement of this theorem: if we have three functions f, g and h, f is a function from a to b, g goes from b to c and h goes from c to d, then h naught of g naught of f equal h naught g of f. That means composite function of h and g naught f equals composite function of h naught g and f. So the proof goes we take the left hand side first, h naught g naught f. By definition of composite function, we get h of g naught f. Alright. Suppose we take h naught of g naught of f of an element x. Then it will be h of g naught f of x. Since g naught f of x, this is also a composite function of the functions f and g. Also, I can simplify it here by definition g of f of x. Right? So, I am leaving it here, g of f of x. This is. Now the right hand side, the composite function h naught c and f of any element x. By definition, what it will be? It will be h naught c of fx. By definition. Again, this is the composite function of the functions h and z. Therefore, again by definition, we can write h of z. H of z and z, here the element is fx. Therefore, z of fx. This is very simple. Only we have to apply the definition of composite functions. We can write here by definition. By definition, actually I am using this. We have already discussed the definition. What was that? If we have two functions f and z, then g naught f of x equal z of f of x. And actually we are using this, applying this, this proof comes here. So if we have three functions, f goes from a to b, z goes from b to c, similarly h goes from c to d, then composite function of h and g naught f equals composite function of h naught g and f. There we does from equation 1 and 2, 1 and 2 gives, directly we can write this equal this because already we have the right hand side equal. Therefore, from 1 and 2, we can write h naught of g naught of x equal h naught of c of x. Hence the theorem proved. So you can see here the whole proof of this theorem. So So this is done. So that's all about this class. I hope you are all getting this, because these theorems are very interesting. I also love them. The theorem number 3 is very amazing. So if you have any queries, then do write in the comment section so that I can help you. Till then, take care. Bye bye.